So in this short video, what I plan to do is test my new focal length finder tool using this script that I've got open here, which is basically what I used earlier on in a previous demonstration to calculate the resolution from the focal length and then later on the focal length from the resolution. I have actually tidied up the notes a little bit because I think this will give a little bit more clarity when we're actually putting the figures into the tool. Okay. So just to recap on these two scenarios, this was the one that was used to calculate resolution from the focal length. And if you recall, we had a lot of rounding up errors with this. We had a very distinctive. If I just toggle the visibility of the plate on and off there, you can see if you look at the bricks there, particularly on where they join with the trees, you can see there the very distinctive pixel shift, which we deduced is a consequence of rounding up the values, which we can see here, which to give their exact values were 1889.52, 1062.85, and we had to round these up to 1890 by 1063, just purely and simply because an aspect ratio requires a whole integer width and height values. This second scenario over here was used to calculate the focal length from an existing resolution, which is typically how you might go if you were going from Photoshop back into Nuke. Okay, so what we did here is we actually started with all integer values, which in this case we went for a larger matte painting of 2500 by 1406, and we used a calculation to calculate the focal length for the camera from that, which we can see up here was 31.744. Again, it's noted down just here as well. And when we were looking at this scenario, we couldn't actually see any rounding errors in terms of the visual representation when we toggle the visibility of one side of the composite on and off. But nevertheless, our sort of foray into the aspect ratio and the way that Photoshop rounds up based on aspect ratio, we can deduce that there are some rounding errors in this, which in different scenarios, if we just limited our approach to this every time without considering it, we would see visible rounding errors using this method as well. Okay, so I'm going to start here, given that this was the one that gave us the most obvious rounding up errors, and I'm just going to copy this entire section and paste it down here, and I'm going to bring my viewer down onto this scenario as well. So this is just a replica of the previous one. Okay, so if we just quickly put our viewer on the plate, we can see that the plate is 1280/720, and we rendered out a frame from this plate at frame 50, which was going to be the basis of our matte painting, and that's what this right now is doing here. This is actually rendering out a frame, which we set it to render out at frame 50. Okay, and that's what we used in Photoshop. Okay, I'll just get rid of that. This is one I've just been working on before. So this is the render. This is the frame 50 render. If I just come out on this, we go into image size. We can see this is 1280 by 720. So this was the 50th frame from the plate. Okay, so let's just quickly jump back into Nuke, and we will put our focal length tester to, or should I say, our focal length finder to the test. So I'm just going to go and get it from my toolbar. I have installed it as a gizmo, and I'll just close off all the property panels so that we can actually see just these values. Okay, so hopefully this is going to help us find and fix the rounding errors. So I'm going to start this process by putting in what we already know to be the value. So if we go down this, we already know the original focal length. We know the original focal length was 62. We know the original resolution was 1280 by 720. So we've got those values up our sleeves to start with. So I'm just going to put those into the finder tool. So 1280 by 720 and a focal length of 62. Okay, so if we if we look at this now, we can see that that has already automatically calculated the aspect ratio. So just to use the scenario from the previous example, we had a new width of 1890, or that's at least what we rounded it up to, so I'm just going to put that in as my new width, just so that these the new height and the new focal length will actually generate a value of sorts. Okay, and we can see that once we've done this, we've got a couple of things that we can see. We can actually see rounding up errors potentially in two different places, or we can certainly see percentage values in two different places. We can see down here that we've got percentage values in the new focal length. However, we've already established that this isn't a problem because it's calculating an optic as opposed to an aspect ratio. It's not working on a pixel level, which this is, and therefore the software will quite happily accept a percentage within a focal length. What it won't accept is a percentage value inside a aspect ratio, a width or a height value. These have to be whole integers. Okay. So let me just demonstrate how to fix this. This is really cool. This is really quite cool in the way that it works. If I now put my cursor in between the tenth and the units, so that basically it's when I start to move that value, it's moving just by 1 pixel at a time. If I now start to tab up with the arrow keys, you can see that that has a commensurate effect on the height. It's also affecting the focal length, but we're less concerned with that. Now the reason why it's automatically calculating the height is that the two proportions have been locked together by the calculation that's in the new height, which is basically bringing the aspect ratio into the equation. So what I'm doing is I'm just going to tab through this until the height assumes a whole integer value as well as the width. Okay, so at that point there, 1904, you can see that that at that point we get a whole integer value. So if we're pretty tight in terms of the way that we've established our focal length, I mean, when in this particular case we actually sort of overlapped quite a bit, so I gave myself quite a bit of contingency. But if I'd set my focal length pretty much to just cover the screen on every frame, then it might be quite tight, and in those kind of situations we would certainly go up with this value and make our map painting a little larger. We certainly wouldn't be coming down, otherwise we are going to reveal gaps. But just to show this going in the other direction, if I come down, so 1890 was where we started. If I start to come downwards, we can see that coming down to 1888, just 2 pixels, I've now got a whole integer value. So you can go up and down with this particular thing. Because I had quite a bit of contingency in my original setup, I know that 1888 width by 1062 height is going to be perfectly adequate to cover the area that I need to cover on all of the frames. So I'm going to stick with these values here, given that this is closest to our original. And we can see our focal length at this particular point is 42.0338983 to be absolutely precise. Okay, so what I'm going to do is I'm just going to come to my backdrop node. I'm just going to enter these values. Should be able to just pull down on that and get in the right place. Pull down on that to reveal all our values. I'll just reopen the focal length tool. Okay, so our new resolution is 1888 and our new height is 1062. And our new focal length, just to save me typing it all in, I'll just copy that value from the input, and I'll put that in as my new focal length, which is there. So rather than being 42, it's now 42.033. That should mean it's rounded up. I'll go absolutely precise in as though we're looking for precision here. So 9831. Okay, so we've got our new values in our backdrop node. We can see those down here now. Okay, so how can we use this information? Well, it's quite simple really. All we do is we go back to our Photoshop file, and this is the canvas that we need to extend, and we can now come into canvas size and we can extend it basically perfectly based on those values. So we know this needs to be 1888 and we know this needs to be 1062. So just make sure that's anchoring from the center. So that is the size of our image. So I'll save that out, and and I'm just going to put the values into this into the name. So 1888 times 1062, and then we'll be absolutely sure we've got the right file when we bring that back in. So I've saved that out, this file here. This is obviously, I wouldn't be saving it out and putting it into Nuke, obviously in a real project. I'd be starting the map painting. But before we do that, we can test this by bringing it into Nuke, which I'm now going to do. So I'm just going to read it in. I'm doing so by dragging from my folder, which is off screen. So this is my new map painting, which we can see on the backdrop is 1888 by 1062. So this is our new file. And I'm just going to quite simply just replace our old one with the new one. The last thing that we need to do is just open up our projection camera, and we need to take our new focal length value, which we established down here. So I'm just going to copy that, and I'm just going to come into the projection camera and I'm going to paste that in. As you can see, I've already done so I know it's right. Okay, so we should now be able to test this image. So again, I'm going to zoom in quite closely, and again, if you focus on the area where the brick joins the trees, I think that's where you can see it most noticeably. And now I'm going to start toggling the plate on and off, just by disabling and enabling the merge. And you can see now that with the aspect ratio of the map painting absolute now with no rounding errors, and our focal length set within the projection camera, you can see that as I'm turning that on and off now, there's absolutely no pixel shift whatsoever. So what we've done now is eliminated the rounding errors from this, and we've got a perfectly aligned image to the map painting, to the plate. So therefore we can confidently now paint on this and extend in this direction or this direction, extend this map painting, and know that when we bring it in, it's going to align perfectly. So I'd like to say that the calculation tool has passed its first bench test. So I'm now going to just bring my cursor over here, and I'm going to try it on the second scenario. So again, I'm copying the nodes and pasting them from this tree, just so I don't disrupt the original one. Got the focal length finder tool here. I'll probably hang on to it because it's got some known values already in there. Okay, now if you recall in this scenario, if I just put my playhead on this is the map painting. We actually created this at 2500 by 1406, so we're dealing with a different scale of map painting here. So this was where we came from Photoshop into Nuke. So I'll just close down all these nodes and then reopen the focal length finder tool. So in this scenario, we wanted our new height to be 2500. So in this particular scenario, again, if I just bring in my the original plate from frame 50, in this scenario, we've decided that it's necessary to bring our disable that so that it generates a new layer, that I needed to bring my canvas size to 2500 by whatever the other value was. Was it 1406? I'll just check. Yeah, 1406. Working pixels, Pete. 2500 by 1406, and this was our map painting size. Okay, so go back to our focal length finder tool. We can see that just by putting in that 2500 value, we can already see that our focal length finder tool has found the rounding up error. Again, it's placed percentage values in the new focal length and in the new height. As before, we're not concerned about the new focal length because it will take percentage values, but the new height is out only by a quarter of a pixel, but that's probably the reason why we didn't see it. but nevertheless there are rounding errors that would trip us up on other projects that have got different dimensions and different requirements. So again, what we need to do is that we need to eliminate this. So how might we do it? Exactly the same way as before. Put our cursor into there and then start to tab. In this case I'm going to go upwards because I've determined that 2500 is sufficient to build my matte painting, no less. So I'm actually making this a little bit larger, and you can see that what I'm doing is I'm just tabbing up 1 pixel at a time, looking for the height, the new height, to achieve a whole integer. And you can see there at 2512 we get a 1413 height value. So again, I'll just open the backdrop and put those in. Okay, so my new height is 2512, and the new width, the new width is 2512, and the new height is 1413. And we can see that at these dimensions our focal length, a new focal length is established, which I'm just going to copy, and I'm going to put that into the new focal length as well. Again, it's rounded that up, which I don't want it to do. So x2 3 5 6 6 9. Again, that rounding up would have been adequate, but just to be absolutely precise, we now know exactly inside our backdrop what the actual dimension should be. So we've got whole integer width, whole integer height, and we've also got a new focal length for going into our projection camera. So essentially the way that we would use this, I won't actually do it, but the way that we would use this back in Photoshop, we would create this canvas, set it to 2512 by 1413, I think we established. We would then save that out. We would then import that into Nuke and replace this one, and we would make our focal length change in the projection tab. We'd be putting that in there, okay, and we would have eliminated any possibility of any rounding errors, creating us any pixel shift issues. Let me just offer up one more scenario while we're looking at the focal length finder. Let's say that we need the new focal length to be as close as possible to a specific value. So let's say, for example, that we've been working in Nuke, and we've established that the optimum we've been scooting up and down our focal length, and let's just say, for argument's sake, that we've found a value of somewhere in the region of 52 to be a perfect position for giving us the overscan that we need for our particular image. That value certainly isn't going to work in this particular case, but I'm just setting that up as an example. So we've established that at round about 52, or a focal length of round about 52, that is the perfect position where we want to generate an image. So how might we use the focal length finder tool for this? Well, essentially we would do it in exactly the same way. So what we would do is that we would come into our into our new width setting, and then we'd start to change our matte painting. I'll actually go up in higher values to get it up somewhere near the bracket. Okay, so we can see I'm up at around about 52. So now I'm going to come down, and you can see that I can get pretty close to a focal length of 52, in this case 52.005, which I will copy, okay, and then put that into my projection camera. Yeah. So I know, I would have to make a slight change on this because I'd have to get my high value the same. So again, I'd just be moving around this, looking for a whole integer value. So there, around about 1520. We've got a focal length here of 52.2, which again isn't too far away. So again, I would just be putting that in to my projection. projection camera. So now in Photoshop I'd be creating a matte painting of 1520 by 855, and then in my projection camera putting in this focal length 52.2. So even though I haven't got perfect on 52, I'm only 0.2 over that value, and I've got all integers in the width and in the height, so I'm not going to have any rounding errors arising from the resolution of the image. So I think I'm quite happy that this tool will help me eliminate any rounding errors when I'm using both of these methods of overlap. So I'm going to wrap up there. I hope you found this demonstration useful.